Hi there! Welcome to Week 7, Activity 1. In this video, we're going to explain how to calculate the distance from a point to a given line, and also how to draw usable diagrams of 3D situations. So let's get started. We want to find the distance from the point P to the line through the point Q. Now, if I were presented with this problem, I might want to start drawing a 3D diagram of what's going on. Right, I would draw our Cartesian coordinate system. I'd draw the point P. I'd draw the point Q. And then a vector representing D. And I'd get a situation that looks like this. So what I want to do is I want to find the shortest distance from P to the line through Q. Looking at the diagram, I can see there's many possible positions to do this. But the diagram isn't especially helpful in finding the optimal distance. So what we're going to do is we're going to pick a diagram, a more useful diagram, that's adapted to this situation. Okay? For almost any point and any vector, there's going to be a unique plane that contains that point and that vector. So what we'll do is we'll draw our diagram from that perspective. We'll draw our diagram in that plane. So here we'll have the point P, the point Q, and the direction vector D. Okay, so now we've picked that plane, and now we've got a planar situation that we can draw. Okay, so we notice that the shortest distance is when the line from P is perpendicular to the line through Q. So the length that we want to calculate is this length here. And what we want to do is we want to find a way to calculate that length using linear algebra. So what we can do is we can introduce a new vector from Q to P. Let's call that U. And then this distance here will represent the projection onto D of the vector U. Right, so we know the points P and Q, so we know the vector U. We know the vector D, so we know the projection of U onto D, and from there, it's a simple matter of calculation to work out the length we're looking for. So we can represent L as U minus the projection. Then we can rewrite U using the points P and Q. Substituting in the points P and Q, we get values for the vector QP. Now we can rewrite the projection. Calculating out those dot products gives us -4/2, which is really plus 2 times the direction vector. And doing the arithmetic, we get that L is represented by the vector 1, 1, 1. Taking its length, we can conclude that the distance is the square root of 3. Okay?